Present value of an annuity. There's the formula right here. Spoiler alert. But let's see, what is this all about? So far, we've done lump sum. In a lump sum, we put one chunk of money right here, and it grows into a bigger chunk of money at the end. And that kind of makes sense. Then we saw future value with regular payments. We started with no money, and then we put money, and at the end, we're going to have a big chunk of money, a nice big chunk of money at the end, like we're saving for something. And then we have this situation in where we start with a big chunk of money, and then we have payment, and the last time you pay something, you owe absolutely nothing. So it's kind of opposite. On future value, we go from zero to a lot of money, and from here we go from a lot of money to nothing. That means that we are paying something off in most cases. So that'll be like a loan. So what are some situations that apply to present value? More important than anything is what I just said, the loan. And this is going to come when you buy a home, when you buy a car, when you buy a motorcycle, when you buy whatever you buy, when you put money in your credit card and you pay on regular payments. That's not necessarily the case. So anytime you borrow money, that would be it. But there's also other cases. For example, how much money do I need to deposit now in order to receive regular payments of X for X time and have nothing left at the end? What would this apply to? I need to put money down so I can take it out little by little. And that most likely would be your retirement. So a very important consideration. How much money do you need to have by the time you stop working so that you can take a little bit of money, and it lasts you for the rest of your life? Very difficult thing because we don't know how long we're going to live. But then this is also something that you can do. You get a present and you say, okay, in university, I want to be able to have this much money for fun. So I need to put this much money down now so the interest will pay me a little bit and I can take money little by little and guilt-free. How much money do I deposit today to set up a scholarship? Hopefully some of you guys will be in that position at some point in time. Or how much are all these future regular payments worth to me right now in today's dollars? And that's where the present value kind of comes from. So we know that if I offer you $1,000 now or $1,000 in the future, you'd rather take $1,000 now. But the challenge comes when I start saying, okay, what if I give you $1,000 for the next 10 years, you're gonna get $10,000. Or do I give you $10,000 now? Clearly, $10,000 now is a lot better. But what if I say I give you $850 today or $1,000 for the next 10 years? Now we can't really compare it, so we use present value to figure out, okay, all those regular payments, $1,000 a year for 10 years, how much are they worth to me today? How much money can I put myself today down so I can make my own regular payments? So let's see an example the long way. How much will you need to deposit today so that you can take out regular payments of $1,000 per year for 4 years if the account pays 6% per year compounded annually? So we can think of it as making it in 4 separate questions. So for the first one, in 1 year, I want to have $1,000, right? I want to have $1,000. So then I can calculate it by saying $1,000 times 1.06 to minus 1. So I know that 943.40 will grow into $1,000 in a year. And then I'll do the same calculation for the other 3. Now I did it previously, so I'm just going to bring the numbers down, up. And let's see. So I need only 890 because it's going to grow in 2 years. It's going to grow to $1,000. I need 839.62 because in 3 years it's going to grow up to $1,000. And I need only 792.09 that in 4 years it's going to grow up to $1,000. So when I add them all together, I get this number. So in order for me to get $4,000 or $1,000 every year for 4 years, I only need to deposit $34.65.11. And that's kind of good. It also means that the value of $1,000 for the next 4 years for me today is equivalent to $34.65. So less money needed now, more money comes for the future. But this is all fine and dandy. But if we have something that's compounded daily or compounded quarterly or compounded monthly, this calculation is very inconvenient. So we're going to go to a formula. And the formula is like this. PV is equal to PMT. Sometimes I call this R. I just like to write it R for regular payment instead of PMT. 1 minus 1 plus I bracket to the negative and everything divided by I. Notice that the top part is the same thing but backwards from the future value. So there used to be a bracket minus 1, now it's 1 minus the bracket, and that the exponent is negative. That's very important. I strongly recommend that you write this formula with brackets on the I, because when you put the brackets on the I, you will not make a very common mistake that people do. So in our case, our present value, we don't know what it is. Our future value is going to be 0. So we're going to have nothing left by the time we're done with this 4 years of taking out $1,000. Our payment is $1,000, and our I is 0.06. Because it was compounded annually, we don't need to convert it to do anything. And N is the silly question. So how many years are there in 4 years? That is definitely the silly question. It's just 4. So when we plug it in, we get like this. It's not 600, it's 1,000. Just change that. 1,000 times 1 minus bracket 1 plus 06 to the negative 4 divided by, use the brackets even though they're not needed right here. Get used to putting the brackets when you divide it, otherwise when it's a fraction you'll mess it up. And your answer should be 346511, which was exactly what we got by adding it all up. So there is our main formula. Make sure that you know how to plug it in, and you can get the answer.